Guys, welcome to my YouTube channel. I hope you are fine, and all the previous lectures of statistics are also going very fine for us. In the last lecture, we studied about the qualitative variables, where we studied about nominal and ordinal. Nominal means the data set which is not like the categorical columns which are not in the particular order is called as nominal, and which are there in the proper order we call it as the ordinal that we studied. So today we will going to study about the quantitative variables. So what are the quantitative variables? I'll explain you with this example. So now here if you see this particular table, here you see this annual column. Here it is having the number 37,000, 49,000, 58,000. So what are these? These are the numbers. So the columns the variables where the numbers are present, then numbers are present where the numbers are present. So those type of data are called as the quantitative data. Qualitative means categories. Like if you see the example of number of pets, here you are having only three categories, four categories. So this type of data is nothing but the categorical data. But here, since the income is in the quantitative number format, so that's why it is called as the quantitative data. So this particular household ID is also a quantitative column, quantitative variable, because here also it is having the numbers, countable numbers. So that's why it is called as the quantitative data, as it is basically dealing with the numbers. So I hope you got clearer idea of what is the qualitative data, what is the quantitative data. So now we will going to study about the types of quantitative data. There are two types of data. One is the interval, one is the ratio. Now I will take this example, this dataset example. In this dataset, if you observe, Mumbai is having the temperature of 25 degrees Celsius. Mumbai is having the 25 degrees Celsius in the morning, and afternoon temperature it is having 25 degrees Celsius. When you take the difference, it is 0 degrees Celsius. So what is this interval kind of data? Interval kind of data is type of data where this zero has some value and or value or meaning. Meaning is there where this zero has the meaning. Where this particular zero has the meaning. Zero has meaning. So this is very important. 0 degrees means what? It doesn't mean it doesn't have value. 0 degrees Celsius means it is in the freezing state point. So this 0 degrees Celsius has some value. So the intervals are those kind of data where if you take the difference between the two quantitative aspects or two quantitative numbers, the result that you get, it should have the meaning. The result of 0 should have the meaning. So that type of data is called as interval data. The second type of data comes is the ratio. Now in ratio, let's say if you guys know, right, like if person's income is 0, does it makes any sense? No, it doesn't make any sense. So here what happening here, this 0 doesn't have any value. So here this 0 doesn't have any value. No value for 0. For 0. So this kind of data where 0 doesn't have any value is comes under the ratio type of data. So we will go into the slides and we will check some points regarding these things. So we'll go to this presentation. So what are the quantitative variables? These represent the measurable quantities. Here there the prices are been measurable in the number format, it is there. So numerical scales with equal intervals but not true zero. Not true zero means what? Here this zero has some meaning. Here this zero has some meaning. Meaning is there. Meaning is there. So if zero has the meaning, then the data is said to be interval variable. But if it has a true zero value, means this zero doesn't have any value. No value of zero. No value of zero. Value of zero. So this is like height, weight, age, salary, zero doesn't have any value. This is the best example to explain ratio in this. Now, what is population? What is sample? So in the last lecture, I discussed about the population and sample. So now let us say this particular area is Delhi. In Delhi, you are having all the regions of Delhi represented in these circles. But to analyze, to make conclusions out of this data, if you are having the population data, it is very difficult to analyze this data and make predictions out of the data and make conclusions out of the data. So that's why instead of the entire population, what we will do, we will select only some particular areas, and for that areas we will do entire analysis and make the insights from it. Let's say I'm taking this data and this data, so out of this entire thing, what we should have this data and this data. So what are these two data? These two data are nothing but the population sample, sorry, where out of the entire population, let's say you are having all Indian population, instead of 150 crore population, analyzing 150 crore population or taking survey of 150 people is very difficult. Survey is difficult. That's why what we will do, we will select it into groups. We will take 100 people survey, and based upon the 100 people survey, we will analyze and we will predict the results. So this is nothing but the concept of population and sample. So now there are some sampling techniques that we are having. One is the random sampling. Okay, now you understood what is sample. Like here, this particular thing is there, this particular thing is there. So instead of all of these regions, we are only selecting the particular sample. So what is random sampling? Here, let's say here this is the entire population, correct? So out of the entire population, you will randomly select some values. Let's say I will select, let's say this has some value, then I'll randomly select this thing, then I'll randomly select this population, and I'm randomly selecting this population. So what you are doing, you're randomly selecting the samples. You're randomly selecting the samples. So that is why it is called as random sampling. So what will our sample data look like? It should be this, this, and this. Means we're randomly selecting the samples. So this is nothing but the random sampling. The second sampling comes as stratified sampling. So in stratified sampling, what you will do, this is what many, like our Indian, like many people implement this stratified sampling. It has very lot of examples, various examples it have. Now let's say, what does stratified sampling do? First step of stratified sampling is it will divide it into groups based upon the similarities. Okay, we will divide these areas into groups. Like we are having different parameters for it, like depending upon the area, depending upon the closeness of the area, depending upon the education level of people. So let's say here this is nothing but the entire students population. So out of this, what we will do, we will select the we will split the population into three different groups based upon their education. So what we will do here, I will change the color to red. So first group will be red group. Okay, red group. Second group, we will split the data into three different groups. So this is the blue data and this is the green data. So first step, what you had done, you had created the different groups based upon the similarities. Then second step, what you have to do, out of in that particular group, in the particular group, select the random samples. Select the random samples in groups. Random samples in groups. Samples from groups. From groups. So this type of sampling is called as random sampling. Let's say if we are selecting this particular data, and this particular data. So what will be our sample will be? It will be like this, and this. So what you are doing, you are selecting the first we are creating the group, and in that group we are selecting it like in that we are doing random sampling. So this is the stratified sampling. Now the third sampling is systematic sampling. Now see, which each and everyone should follow. See, let's say you are giving like right, to go into USA you require H1C visa, right? So that visa only some of the few people will get. So what we will do, kth in select every kth individual from the list. Let's say these 9 people are there. So here I am putting condition that choose choose every third person, every third person, third person. So this condition is mandatory, but you have to specify the starting point. From that only it will work. You have to specify start value. Okay, specify start value. So now what I will do here, I will specify this value as the start value. This particular color represents the start value. Here I will write also, it represents start value, start value. Okay. So now what I will do here, now I will do the k-fold sampling. So here k means what? Third person. So here from this particular point, every third individual you have to select. Okay. So what will it happen? Now here I'll change the color. I'll keep it as blue. So the next one, we will either go from right side order, we'll go from the bottom, any order we can follow. So now we are going in this particular order. Okay, this order we are going. So now what will we do? This 1, 2, 3, correct? So this will be your first step. Then from after here, you have to go from here. So 1, 2, 3. So this is the third element. So now if you check here, one, there are no second, no third values. So what are the points you selected? You selected 3 points. What are those 3 points? You selected this point, then you selected this point, you selected this point. So here what is happening? It totally depends upon your luck. Okay. So but you are giving fair opportunity to everyone. That is the systematic sampling. Okay. Now fourth one comes is clustering sample. This clustering is very important when we deal in machine learning also. Okay. So in clustering, what will we do? Like stratified sampling, first we will create it into three different groups. We will divide it into different groups based upon the common features and functionalities. Then we will go to this particular this thing. We'll create this group and we'll create the green group. Okay. So the difference between the stratified sampling and clustering sample is, here you will select the entire cluster. Here you will select the entire cluster and you will pass all the elements of the cluster. So what does this mean? Let's say here you selected the red cluster. Okay. In red, what are elements are there? Three elements. So all three elements will come in the sample. So here I will take eraser. Sorry. I'll go to sample. Not, yeah, this should be black color. Okay, no issues. We'll be creating black sample. Here it will come three circles. And what are these three samples? These three samples are red samples. Why red samples? Because we have selected this particular cluster, and in the cluster, all of the elements which are present in this cluster will come here. So what is the real life example for this? Let's say you have to find the height of the entire school. You cannot find the average height for all the students in the school, because it will be large amount of data, and analyzing that large data is difficult. So what will we do? We will divide the people into different groups, like first class people one group, second class people one group, third class people one group, fourth class, like the 10 groups will form. And we will select one particular group. Let's say we select the 10th class, and in the 10th class, for all the students we will calculate the height, average height, and that value we will give it to that value we will tell that, okay, in our school we are having the average height of this much height, the average height student has. So here this is one of the best application of clustering sample. So these are the four samplings that are important. Random sampling means randomly you select the value. Stratified sampling means you divide it into different groups, and in that different groups you will select the random. So the best example for this is, let's say you want to check the average marks scored by the students. Okay. So for this, what you will do? You will split it into different groups, like first class, second class, third class, fourth class, fifth class, like that, to split into 10 classes. So you take the 10th class. Okay. And in the 10th class you will randomly select the students. That is the example of stratified sampling. Third one is systematic, means you will select the k value, based upon k value the decisions will be made. So I hope these particular concepts are clear. Now we will see the PPT also. Okay, PPT also we'll see. So if you observe, population means entire group of individuals, items you want to study, all students from SRM University, which is my college. Sample means what? Subset of population used for analysis. So 100 students are selected randomly from SRM University is an example of sample. Like here, if you see here, we have selected two random students from the entire six students, and this sample is nothing but the subset of population I already taught you. And then what then we use samples because studying the entire population is very difficult and impractical. That's why we will be using that. I already told. Sampling techniques, we studied about random sampling, where every individual has equal chance of being selected. Picking 50 students randomly using random number generator is one of the example of it. Like you select some random students without seeing any factor. Now, second is stratified sampling. Like here, the population is divided into groups, and these groups are also called as strata. Okay, strata, if you remember, not remember, no problem. We'll divide it into groups, and based on the characteristic sample from the each group. Okay, selecting the students based on year first, second, third, fourth, and here we will do random sampling after dividing it into groups. The third approach is systematic sampling. Select every kth individual from the list, choosing every 10th person on the class. So here in this example, what we had done, we had chosen the three different three what I can say every third person from the group, from every third person from this particular population will be selected, is what we put the condition. So that is what we have been showed here in the systematic sampling. And next thing we had is clustering sampling. In clustering sampling, divide the population into different groups and randomly choose few clusters and use all members within those clusters. So you divide it into groups, and you divide it into different groups, and from that group you will do it for all the population inside the cluster. Selecting three classes out of 10 and surveying all students in these cases. So similarly, 10 classes, selected one class, for that one class we will take average of all the things. That is nothing but cluster sampling. So last topic for this particular section, that introduction to statistic, is statistical data analysis process. This is very simple thing, that is not difficult thing. We'll discuss it now itself. See, to do particular data analysis part, your statistics plays a very important role. So the steps that we have to discuss, first is identifying the problem statement. Problem statement identification is very important when we deal with the when we try to solve a particular problem. You should know what is the problem statement actually about. Okay. The second thing is you have to collect the data. You can collect the data from surveys, Kaggle, APIs, from many different sources. You can also use the synthetic data generation also you can do. In this course, we will study how you can do the synthetic data generation. The third thing is we have to clean the data set. In the clean data set, you have to remove the null values, play with the missing values, play with the duplicate values, and fix the errors which are present in the data set and transform the data structures or data types in it. Then you have to explore the data using the statistical analysis like box plot, central tendency. All the basic concepts of descriptive statistics are used to analyze the particular data. Now, to after analyzing the data, to interpret the data, you have to use the inferential statistics to make the conclusions out of the data. Your descriptive and your inferential both plays a very important role. So to analyze the results and writing the conclusions in the bottom of the notebook is also very helpful. And then last is like whatever analysis you have been done, you have to make a report and you have to tell like what I have performed, what is my approach towards it, and how did I achieve that thing. And after that you have to paste some plots, or you have to paste some report, like you can create the report of explaining how we had done the steps. So this is the process, entire process of doing an statistical analysis statistical analysis. So I hope you understood these basic fundamentals of analysis. I hope you understood the basic fundamentals of statistics, where we studied all the concepts like what is statistics, Then we studied about what are the types of statistics that we have, differential, inferential statistics we have. Then we studied about the population and sample is. Then we studied about population and sample, and after studying the population and sample, we studied about types of data, types of variable, and then we studied about some of the sampling techniques like random, systematic, stratified, and clustered. We studied, and then we studied about the statistical data analysis system. So this completes the first phase that I told. The introduction to statistics is completed. Introduction is completed. Introduction to statistics is completed. So in the next lecture, we will going to start with the measures of central tendency. It is measures of central tendency is very easy. And from next lecture onwards, we will start coding. This lecture does not require any coding as it is entire theoretical stuff. From the next lecture, we will do hands-on coding. So that's it, guys. So I hope you like the lecture. Please do like, share, and subscribe, guys. So thank you, guys, for supporting me till now. So that's it, guys.